It's time to talk about the final and biggest routing protocol of this whole series, the Border Gateway Protocol, but most people call it BGP. BGP is the routing protocol of the internet. It's what makes the internet tick. And if you're really looking to get into BGP, there's a whole series dedicated to it that maps up to the CCIP certification. That's for people that deal with Cisco gear and internet service providers. So why are we talking about it here in a CCNP course designed for the corporate customer? Well, corporate customers also run BGP. It's done very often. We're going to find out why people do that in this opening introductory series to BGP. Why would you run BGP? We'll look at some of the facts about BGP. What makes BGP tick? Then we'll get into how most people implement BGP, the styles of implementation, and then we'll wrap up by looking at how BGP finds the best route around the network. You're going to be really surprised when you see that because it's amazingly simple. And then we'll look at the communication, how BGP communicates, what packet types it uses, and the tables it creates. Let's get going. Let's first off focus on the place of BGP. So far in this series, we've had our faces against the wall so close in our corporate networks, we forget about this massive cloud that is in the rest of the world known as the internet. We've been working with something known as IGPs. I know you know what that means, the interior gateway protocols that make our networks work, allows routing to happen within our organization. But there is a protocol that routes for the internet. It is the one and only external gateway protocol, and that is BGP. Now, BGP is not the first external gateway protocol that was out there. The original one was actually called EGP. that was its name. It was the external gateway protocol. But BGP came out in recent, well, decades ago, but I suppose recent years to really address all of the shortcomings of the original EGP. And now EGP has become a category of protocol rather than the protocol. So BGP helps us find the best way around the internet because you know behind this pretty little cloud is a mass of hundreds of thousands of routers, a network of networks that makes the world work as we know it today. BGP is that routing protocol. It's the routing protocol that allows all of these networks to tie together and work successfully. Let's get a little more focused. The scenario you see on the screen right now is actually one of the most common places where BGP is used. It's when an organization gets large enough that they need dual ISPs. But BGP isn't used for what most people think it is. Most people, when they think about BGP and they start thinking about, dual service provider connections, they start thinking about this direction. Things going outbound. So I have communication that's going to these ISPs, and we think about, oh well, I need to make sure that things going out, gets load balanced, or that people get internet access. When people run BGP, most of them are concerned with this direction. And I'm not saying that the other direction is not valid, but it's not usually the biggest focus. Think about what organizations need nowadays. Most of them are concerned with web presence. They have their web server, they have their email server, all sitting right here within the organization. So they're not really as concerned with people surfing the web as they are people that need to get to their corporate website, or people checking their email, or people VPNing into the organization for remote access purposes, and maybe that's even their branch office connectivity. Organizations want the kind of redundancy that if this ISP goes down, either the whole ISP, that'd be pretty devastating, or just the link to that ISP, the backhoe just took it out and now your internet connection's down, they want to make sure that they have a redundant connection to this ISP, not only for outgoing, but for incoming access as well. So the corporate website does not go down if the ISP goes down or the connection to the ISP does. The way this usually works is you, as an organization, get a public IP address block. Maybe this area has 150.5.5.0/24 that's assigned to their organization. Using BGP, they can advertise that route to this ISP and this ISP. So both ISPs see that internet address, and that gets flooded to the rest of the internet community. So they see multiple routes to reach this address block. Now, once they see that, if this ISP is unavailable, well, they can just go around to this ISP. Now, I show, two of these houses or telecommuters that are connected to each individual ISP. But remember, they probably have this style connection. They're most likely not connected to the same ISP your organization is, or at least not at the same point of access. This might be someone in Seattle, and this is an office out here in Arizona. Okay, so you really have many points of access that they can come in, and they are not tied to a single ISP. The point of BGP is to make your organization typically redundant. Now, let me get all my chicken scratch off of there and talk about another use. This organization may have better paths from one ISP to reach some offices and better paths through another ISP to reach offices. Here's another use of BGP. Maybe, you have T1 lines for both ISPs that you have available. And, these ISPs are connected like this, and you have redundancy and all of that configured for these homes. But this ISP may just have a shorter route. There's less distance to travel. So because of that, BGP may identify this path is the best to use to reach this remote office or this telecommuter, and this BGP might identify this path as the better one to use to reach that telecommuter. Even though the bandwidth is the same, the path might end up being shorter in the long run going through one ISP or another. That's another use of BGP. So really, the two uses here that we have both deal with this term known as multi-homing. We have a corporate office that has a possibility of using one ISP or another. That is known as multi-homing. Before we go any further in the design of BGP, let's talk about the facts. BGP runs on top of TCP. That's very unlike the other protocols we've seen so far, like OSPF and EIGRP. Those protocols are their own layer 4 protocol. They have their own reliability mechanisms. But BGP says, hey, TCP is already in existence. It has its own reliability, so let's just use that. So it is assigned TCP port 179. The TCP ACK messages are used for all reliability. So when an update is sent, TCP sends an ACK back saying, I got it, and now we can move on. If it gets dropped and the TCP ACK is not received, BGP will resend the update. Now the updates I put, of course, are triggered and incremental. That means that BGP will only send an update when something changed and only send what's changed. The reason I put of course on there is compare that to like RIP, which every 30 seconds sends the whole routing table. Oh, can you imagine an internet protocol that does that? The BGP routing table is hundreds of megabytes in size. If it were to send, a full routing table every 30 seconds or 90 or any time interval, it'd just be a massive update. So good news is that it's only incremental and triggered. The metric for this is the biggest you've ever seen. What I mean by metric is what it uses to find the best way around the network. RIP uses hop count. OSPF uses cost. EIGRP, you thought that one was big with bandwidth and delay and some of the other ones that you could throw in there, but BGP is huge. It is a massive compound metric that is tunable in so many ways through these things known as BGP attributes. This is one of the most tunable routing protocols on the planet, and you can imagine with a network the size of the internet, we'd need that. We need the ability to tune this and that and all these attributes for specific routes. So when you say metric, there's no simple answer. I can't just say, yeah, it uses, bandwidth divided by 100, like OSPF. It's this compound list of 10 to 15, I think it's somewhere around 18 different things that all go into that metric. It goes through those attributes, that's what they're known as, one by one, looking for something to break the tie. So instead of saying, this route, let me give you an example. The 10 route right here has, a cost of 50 or something like that. It will say the 10 network is assigned this attribute, this, this. So when it's trying to find, maybe there's two paths to the 10 network. One has all these attributes, another one has, all these attributes. It's going to go down in an ordered list and say, okay, does this break the tie? Is this equal? Okay, it's equal. Let's check this attribute. Is that equal? That's equal. This attribute, is that equal? Is that, going down the list, down we go until finally it says, oh, here's one that breaks the tie. And then it says this path will end up being the best. This one gets thrown away or just gets moved to the back of the BGP table. Now, this is the slowest routing protocol on the planet to converge. It is not fast. A lot of people might be thinking, well, if this is such a great and tunable protocol, I should use this for my internal networks. I should use this, within my organization. Don't do it. That you can. There are ways to do it. It's something known as iBGP, but you really have to tune it to make it efficient. The reason it's slow is by design. Imagine, if there was a network on the internet that went down and suddenly the routing protocol was like, oh, let everybody know, triggered updates, brrr, all across the internet. Think about the internet. How often do you think networks go up and down on the internet? Every second something like that has happened. Every second someone somewhere has a router crash. Every second a cable goes bad. Every second a network card needs to be replaced. Any of those things can cause a network to go down. And when it does, that becomes an update. If BGP were to trigger that immediately to all the routers on the internet would always be in a state of chaos. This is also one of the reasons why, if something fails on the internet, it just takes so long to come back online. Some of that is just dealing with the pain of the slowness of BGP. Now let's focus in on the styles of BGP implementations. The difference between this video series and the BGP video series is the focus. BGP, the whole video series, focuses on the cloud, as if you were an internet service provider. So you get to see the inner workings from the ISP's perspective, ways to keep customers from goofing up your network and that sort of thing. The bsci video series that you're in right now is taking this perspective. The perspective of you as a customer of multiple ISPs running BGP and what you have to do to tune it in the best way possible. Now, most customers that have this kind of implementation will use a default route only scenario, meaning instead of getting the whole internet routing table from both ISPs, the ISPs will either send or the administrator on each side will configure a default route. So for outgoing access, we pretty much use a primary and a backup scenario. Or you can do some basic load balancing, saying, okay, the first conversation goes out this ISP, the second conversation goes out that ISP, but even that is pretty limited with what you're able to do. The main advantage of running BGP in this case is not so much the outgoing access, as I mentioned, but rather the incoming. By running BGP, you can advertise to both ISPs your assigned address block. Remember I was saying maybe you've got 50.5.5.0 or 150, I think is the example I gave before. You can advertise your network to both ISPs. And that way, if this link goes down or this ISP fails, the network will cease to be advertised in that direction. And from there, the internet service providers on the rest of the internet will slowly start converging and moving in the direction of using that ISP because this ISP no longer sees your network. So by using default routes for outgoing access, you just kind of go with the flow. But for incoming access, you have truly designed redundancy into your network. The second style of BGP implementation is to receive partial updates from your service providers. Now, this is useful if you have maybe a corporate office like we have right here with a couple ISPs and some branch offices that have better connections through certain ISPs. Let me give you an example. Let's say that the buildings that you see up at top, this one is maybe in Australia, this one is in Moscow, Russia. Okay, so I'll just put RU. Now, when you've got these offices, maybe they have connections to service providers that are linked up to other service providers that just happen to have better connections through certain ISPs. Same thing over here in Russia. We've got a connection to a service provider. We'll just link it straight up. We have better connections through ISP1. It's not that either of these ISPs have a worse connection from the corporate office. It's just that some ISPs have closer connectivity. You pass through less systems, and thus your delay, your latency is less by the time you get to the other end. Now, when we link up with BGP, either the ISP or us at our corporate office can do some filtering. Maybe this ISP only sends the routes that we need for Russia and Australia. And when I say the routes, maybe Australia has a block of addresses, we'll say 150.1.1.0/28 or something. And Russia has a block of address 160.1.1.1. I think I added an extra one in there. That's /28. So these will be advertised through the second ISP, and we'll receive them here at this connection. And this ISP will advertise those two as well. I mean, they have the whole internet routing table, so of course they're going to know about those two routes. Now, the good news is we don't have to deal with the whole routing table of the internet here on our routers. Either the ISP or us will put a filter to where we only receive those specific routes that we want from Russia and Australia. Once we do, we can then say, okay, now that I know about them through both ISPs, I will set this one as the preferred route to Australia. This one is the preferred route to Russia. At that point, it still knows about both routes, so if this connection goes down, it can fail over and use, Russia through ISP2. It's just we're using the optimized connection when we're going to the specific offices. That's a good compromise without having the memory requirements of the whole internet routing table on your router. The last style of BGP implementation is the full updates. This is the big kahuna. You're going to be receiving the entire internet routing table from one or even both ISPs. So they're sending you the 100 plus megabyte size routing table from the internet over to your office. This one's sending the 100 plus megabyte size routing table as well from their perspective. The updates will look different because the ISPs have different locations. They have different connections, different uplinks to higher level ISPs. So your router is going to receive a massive routing table from both ISPs, and it will store both of them. So it will keep 2 copies, or if you have 3 ISPs, 3 copies, 4 ISPs, 4 copies of the internet routing table. Each one of those increasing the amount of memory your router is going to need. Essentially, that router is going to need a massive amount of memory. Now, of course, it's only going to choose one best path, and that's going to end up going into the routing table, but it maintains all the other paths in it's known as the BGP table. We'll talk about the specifics in just a moment. But that BGP table is maintained, so if one ISP goes down, the router can immediately say, oh, well, I've got some other routes through this other ISP. Click, change over to the other ISP, and use that as a primary, or instead of load balancing, shift everything over to a single ISP. This is the most flexible style of BGP implementation, in that you can really shape your router to route however you want around the internet, but it's also the most resource consuming. Now let's talk about the BGP routing algorithm. Not many people know this, but BGP is technically a distance vector routing protocol. Some people call it advanced distance vector, but really that's all it is. Most people will call it a path vector protocol, and I'll show you why in just a moment. But it's kind of funny to think that the biggest routing protocol in the world is in the same category as RIP and IGRP, distance vector. Now, the funny thing is, without tuning, BGP behaves just like the RIP protocol. Look at this. We've got ISP, we'll say 1 sitting right here. We've got ISP 2 sitting right here. Now, ISP 1 is going to send us all the internet routes. We'll say it's the full routing update style that we just talked about. Same thing with ISP 2. Your router will decide which way is best to reach, we'll say, this office over here, based on hop count, where hop is autonomous systems instead of individual routers. So when it's looking at how do I reach this network over here on the right hand side, the router in your office will say, well, there's 1 hop here, 2 hops here, and then I arrive. Or I could go this way, 1 hop, 2 hop, 3 hops, and I arrive. So obviously this is the best route. That one will not enter the routing table. It does not take into account anything else. I mean, these could be T1 lines, these could be, OC192 connections between ISPs. It doesn't look at anything. So the point is that a lot of times the selection of the route is somewhat random. And most of the time that's okay. But when you have specific routing needs, just like we were talking about with those branch offices in Russia and Australia, you may want to tune BGP so that it chooses the right path for the right connection. Finally, let's take a look at the BGP packets and tables that exist as you work with this protocol. It's simple. There's only 4 packet types in BGP, and they're very logical. There's an open packet, and if you're using Ethereal and you're sniffing these, you will actually see the label open right on the packet. That is sent to start the session. It's kind of like the hello packet for BGP. The second packet type is keep alive, and I just put duh next to that. If you reach this point in your Cisco career and you haven't seen what a keep alive message is, well, you missed something major. All this does is make sure that the neighbor is still around. It's a BGP message that just says, are you there? And the other side replies, yes, I am. And at that point, the hold down timer is reset and the relationship continues. Now, the next one is an update message. This is by far going to comprise the bulk of the messages that you receive with BGP. Updates contain some sort of network reachability. For example, maybe this network went down or this one came up. That's going to send an update which will update the BGP routing table. The last type of message is typically when something has gone wrong. It's a notification message. There's never a good notification. It's something that means there was an error on the connection. Maybe you missed too many packets, or you're in the wrong autonomous system, or something to that effect. Your neighbor configuration got goofed up. Notifications will close the session between two neighbors. It means we're done speaking. Now at the bottom, you see the 3 tables that BGP maintains. Again, very similar to some of the routing protocols we've seen for the inside of our network, the IGPs. The first one is a neighbor table, which has all the connected BGP friends. These are all the neighbors that you have configured for BGP. Notice I said configured, because BGP is very different with neighbors. It doesn't just auto-discover them and form neighbor relationships. You type in who your BGP neighbors are. Second one is the BGP table, which is a list of all the BGP routes that have been received. And this one can be big, enormous. This is the one that receives all the routes from all the ISPs, and then it decides on which one is best, and those go in the routing table. So the BGP table can be potentially double or triple or quadruple the size of the routing table, depending on how many BGP neighbors you have or how many ISP connections you're maintaining. And that is the conglomerate of BGP foundation concepts. It should lay at least the concrete slab that we can begin building on for BGP. I know there's still a lot of gaps, a lot of holes in where BGP fits and what router should run BGP, but that's what we're going to talk about as we continue on. So just to hit the high points, we saw the place of BGP in your routed world. It's not for everybody. It's typically for businesses that have 2 or more internet connections where they're load balancing inbound connections or needing redundancy for inbound connections to their web servers. The other place would be if you were an ISP, if you were an internet service provider and needed to exchange routes with other ISPs all around the world. We saw the facts about BGP, that it uses TCP, port 179. We saw that BGP is, really just a fancy distance vector routing protocol, which by default uses RIP's method, the hop count, where hops are autonomous systems as it moves between its different destinations. We saw the styles of BGP implementations, the default routes, partial updates, and the full updates. And finally, we looked at the message types, where we were looking at the types of packets, the 4 types we just saw, and the 3 different tables that BGP maintains. I hope this has been informative for you, and I'd like to thank you for viewing.